Hello there, everybody. This is Cole from the Arizona Science Center. I hope you all are having a great, wonderful, and most importantly, safe day wherever you are. Me, personally, I'm in our basement classroom right now to make sure that I can deliver this message to you without my mask while safely social distancing away from our amazing coworkers that we have here. Now, you might be wondering where your normal Facebook Live team members are, and don't worry, they're coming back next week. But this week, they've given my team the reins, the Guided Experience team, to essentially give you a sneak peek into what you can expect from our guided experiences. Now you might be wondering, Cole, what the heck is a guided experience? Well, essentially, since COVID hit, we at the Arizona Science Center have been developing, brainstorming, and innovating a brand new type of experience for you to all enjoy in person here at the Arizona Science Center in the safest way possible. And that experience is the guided experience. We have 4 guided experiences that essentially cover 4 different disciplines of science and are chock full of fun activities and memories for you, your friends, and family. The ones we're going to be talking about today is our Stellar Space Science guided experience that talks all about interplanetary travel and what the future of space is for humanity. The activity we're going to pull from that is all about rockets, appropriately enough, right? You can't talk about space without talking about rockets. And we're actually going to be building our very own rockets right here. So before we get into anything, let's talk about what makes up a rocket, right? So rockets are inherently incredibly complex machines. There's even the old saying, right? At least it's not rocket science. Well, you literally need rocket science to build one of these. That's how complex they are. But thankfully, we can break down a rocket into 3 basic and easy to understand parts. So much that you can then learn those parts and build your very own rocket at home. Well, your own rocket in a certain way. So let's go over those parts real fast. So at the very, very tip top of this rocket we have right here, we have our nose cone, or just our cone. So we have our cone, right? I'm gonna do little body movements to help learn. They're silly mnemonic devices, but the sillier the mnemonic device, the easier it is to remember. So we have our cone, right? Essentially, the cone's main job is to help the rocket cut through the air in the most efficient way possible. When rockets launch off of their launch pad, they're fighting a ton of wind resistance. It's kind of like when you're in the bottom of a pool and you shoot up and you can feel all that water against you. The same thing's happening to a rocket. So if you are jumping up from the bottom of the pool and you put your hands up like this, it's a lot easier because you're cutting through the water more efficiently. Now rockets don't have hands, but they have these nose cones to help them cut through the air more efficiently. Also, the nose cone is normally where your astronauts will be as well. That's where they're all in, that's their command capsule, module, that's where they're staying during the space flight. So we got the nose cone, right? Let's talk about the next part. That's this big, long part right here. That's what we call the body. So the body of the rocket is essentially what holds all of the fuel. Rockets are very, very heavy, and because they're very heavy, they need to have a ton of force pushing them off of our planet, fighting the gravity that our planet has. And in order to do that, they need a lot of rocket fuel. So normally this entire thing is essentially filled up with rocket fuel. Next, finally, but most certainly not least, we have our fins at the very bottom, and you can see them right here. In my opinion, the fins are the most important part of the rocket because without the fins, you can't really control where it's going. Essentially, the fins help direct the rocket to exactly where it needs to go, and when it comes to space travel and space flight, being as precise as humanly possible is incredibly important, not only for the safety of the mission, but for the safety of the astronauts aboard as well. So, we got our 3 main body parts, right? Say it with me. We got our cone, we have our body, and we have our fins. So now that we have all 3 of those in mind, we can now finally build our very own rockets. So let's go ahead and talk about the materials we have right here. I have 2 small pieces of paper. The more colorful, the better in my opinion. I have a Sharpie for marking things down. Nice pair of little scissors. I have a roll of masking tape. We have a PVC tube, PVC pipe, that fits the same size as the PVC pipe on our launcher right here. Now that part is incredibly important, and we'll talk about why in a minute. So let's go ahead and start by building the most basic and the most, well, one of the more important parts of the rocket, the body, right? It's the biggest part, we might as well start with that. So what I'm gonna do is I'm gonna take one of the pieces of paper and I'm just gonna give it a little roll. I'm gonna roll it up on here. You can do it long ways or short ways. I like to do it short ways just because I like my rockets to be a little bit shorter. And so you're gonna roll it up, you're gonna make sure it is all flat and even. And the trick with this is you wanna make sure it can slide back and forth easily, but it's also not too loose. All right, so let's go ahead and take that. You're gonna slide it off and put some tape on there as well. Now it's all secured. I'm gonna add a little bit more tape as well just to make sure that it is nice and sealed. So we're not using any rocket fuel with this for multiple reasons, right? Rocket fuel is incredibly expensive. It's also very dangerous and flammable, and I don't wanna deal with any of the paperwork that it takes to get real rocket fuel with this. We're also building with paper, so fire, rocket fuel, not the best thing. But for a fuel source, we're going to be using our air compressed with this bellow. It's going to hopefully launch our rocket out that way. So we have our body now. Next, let's focus on the cone. So before I make the cone, I want to make sure that I'm able to stop the air shooting from this tube and have it go and hit this. So essentially that's where our force, that's where our lift is going to be coming from, is from the air shooting into the top of this paper tube. And moving the body like that. So we have this all sealed off now. It's time to make the cone. Now the way we like to make the cones here, there's on a Science Center, we're going to take our masking tape tube, lay it down on the table, and we are going to go ahead and draw a perfect circle, or as perfect of a circle as you can make. Put a little dot in the middle. We're going to then cut it out. And while we're cutting this out, one thing you need to be sure that you're thinking of is how big of a cone do I want? Do I want it to be really small and narrow? Do I want it to be a little bit larger? I personally prefer the more narrow ones because they help you cut the air a little bit better, but that is just me. I'm going to then cut out what I call a pizza slice to make a little Pac-Man. So we have this right here. And then what we're going to do is put one end over the other, make a nice little cone just like that, and apply some more tape to hold it in place. Let's go ahead and get that done. Real fast, friends, if you want to be a rocket scientist, or heck, if you just want to tell me what you want to be when you grow up, what kind of scientist you want to be, go ahead and drop in the comments. We would absolutely love to see it. Also, if you end up doing this activity and want to make your very own, send us some pictures. We would absolutely love to see that as well. All right, I'm going to fold this over so it fits a little bit better. Add some more tape. Now, rockets aren't meant to be entirely pretty. Aesthetics are very important, but so is function. All right, and then I'm going to apply this right here. So now our body of our rocket has almost an arrow-like quality, right? Now, last, and again, not least, we have to add the fins so we know where it's going. So most fins are triangles, just because triangles are one of the strongest shapes out there. But if you're doing this at home, or when you're doing it with us at the Arizona Science Center, I hope you'll explore and try to do some new and exciting fin shapes. All right, I'm going to break off some pieces of tape. We're going to put these fins on there. And we're going to see how well my rocket flies. All right. All right, let's give this a go. I need your help, friends. We have the rocket right here. Let's go ahead and put it on there and give it a good launch. Ready? 3, 2, 1. And there we go. So we learned about the 3 parts of the rocket. We learned about how rockets fly, essentially. If you want to see more activities like this, or want to learn more about space, go to our website, go ahead and sign up for one of our guided experiences. We have several of them running each and every day except for on Tuesdays. And we hope to see you not only in the next video, but here at the Arizona Science Center to enjoy our guided experiences. Thank you, everybody. Have a great day.